There are two structural frames used on the Teaching and Learning Building project, an in-situ concrete frame, which is what we're standing on now, and then there's a self-supporting steel structure, which is what the crystal is for. When we were looking at how we were going to control quality on that project and ensure quality, we looked at the traditional surveys that are normally done and thought, well, we'll bring in our 3D laser scanner. Whereas the robotic total station takes 1 point at a time, this takes millions of points. We use the laser scanning, so not only did we use the laser scanning for the crystal part, we also used it for everything else. What was really key, and one of the big challenges that we had with the crystal, is that we had to order the stove end tech glazing before we had the steel fabricator on board. What that meant, we had to get as early engagement as we possibly could with the steel fabricator, make sure that they were creating the 3D models that we needed, which we could then overlay onto the design. The way that the steel was fabricated too, because of the length of the steels, there was about 40mm manufacturing tolerance. However, the stove end tech had a 5mm tolerance, so what we were actually working to was 5mm. So we did laser scans. That means that we can then overlay that onto the design that the steel fabricator had done and then see what was actually installed on site. Is it what they actually designed, or has it been slightly moved? Next, the other kind of critical part was the Glulam Roof. So the Glulam Roof, I think it was designed in Germany, it was made in Austria, and then it was delivered to the University of Birmingham. So we had a separate model for the Glulam Roof, and it was that highly detailed. For example, the Glulam Roof even modelled the packers that then the glulam sits on top of the steel, which then allows for the deflection. Tolerances had to be millimetre perfect. Because we were assured that the design was there, we were laser scanning, making sure that there was no deflection when they were installing the steels to start with. And then when this Glulam Roof arrived on site and it was lifted in, every piece went in perfectly. Laser scanning is a great tool to be used. It's a really good audit check. One of the key benefits is kind of giving that built-in, the assurance. For the example of the crystal, because we've got virtually everything modelled, it allowed us to start trying to play construction rehearsals, so we could start to see how stuff was being built, what temporary works might we need to go around that to facilitate that work to be conducted. That meant that we managed to fit 730 unique sized pieces of glass right first time. So one of the tools that we've used quite a lot is the Matterport Camera. So a Matterport Camera pretty much creates a Google Street View of your building. We'll do it throughout the construction process, and we'll also do one at the end of the project. So we've got a good photographic record of the whole building. So at the end, once I've finished scanning, I upload it into the cloud, and then that can be then sent to the build team. Build team can then use it in their progress reporting when they're talking to their senior management, directors, etc. And then that can also get sent to the university, so the university were also using it for their director of estates, etc., to actually showcase where we were at on the build. All our main supply chain and consultants should be producing 3D models. So we would expect a 3D model from architectural, mechanical and electrical, structural, civil, landscape, and then we might pick out key areas then. So in this case, it was the steel frame and the glulam. What it would allow us to do is start to have a bit more engaging, collaborative meetings. We'll be using our BIM cave to actually showcase the model, showcase the different parts, elements of that model. BIM's not just about 3D models, it's more about the information that goes within these models. So the customer has defined what they want to know about pieces of kit, whether that's a wall, door, furnishings, that type of stuff. That then means that they can then run their facility using the 3D models that we've produced, that we've validated, that we've verified. That allows them to run their facility much more efficient.